Morning, students. Myself, Vijay Shankar from EC Department, Chipral Engineering College. Today, we are going to discuss about the correlation examples. So, what are the different types of correlations? And briefly about the correlation, and can discuss about some examples in the autocorrelation and cross correlation. See, correlation is basically used to compare the two signals. Correlation is basically used to compare two signals, or it is a measure of degree to which two signals are similar. Correlation is basically used to compare the two signals, or it is a measure at the degree of to which two signals are similar. There are two types of the correlations: cross correlation and autocorrelation. The cross correlation is between a pair of signals or a sequence X and the Y, the time domain signal X of t and the Y of t is given by R of, here it shows the gamma, actually it is R of xy of tau is equal to, one signal is a normal signal X of t, another signal is shifted with the tau samples Y of t minus tau d t. R of xy of tau is equal to X of t is a normal signal and the Y of t is a delayed version of the tau samples, or we can also written as the X of t and the Y of the complex function of t minus tau dt, or integral minus infinity to infinite, the X of t plus tau, the advanced function, into Y of t also the same dt. And we can take the any one of this complex function x conjugate of t plus tau into Y of t dt. So these two signals are delayed signals of Y of t minus tau and the Y of t minus tau here. Any one is a complex. And the X of t plus tau and the t plus tau is advanced functions. Advanced function. Got it, my dear students? See, the R of x, y of tau is equal to, or L is equal to. Here you take the tau and, or otherwise you can take the L. Sum of n is equal to minus infinite to infinite, x of n and y of n minus L. It is in terms of discrete function, and integral is in terms of the continuous time function. Okay. The superscript of xy indicates that x of n is a reference sequence that remains unshifted in time x of t, and y of n is shifted with the L units in time with respect to the x of n, L units, or here it's a tau units. The continuous time function is a tau, and in the discrete time function, L units is shifted. So one is unshifted in time, another one is shifted in the time with the L or the tau, depends upon the continuous and the discrete. If you want to fix y of n and the x of n is a shift of x of n, or y x of L is equal to the y of n and x of n minus L, can also shift the any one of the signal. If one signal is a normal, another signal is a shifted version. Or, and again, it is a sum of advanced function also, the y of n plus L x of n. Got it, my dear students? If the time shift L is equal to 0, then we get R x y of 0 is equal to R x y of L actually, or the tau 0 is equal to. It's a sum of n is equal to minus infinite to infinite. Either it is a x value or the y value is shifted, or the shifting is either in the advanced or the delay also. When the tau is equal to 0, it becomes of x of n into y of n only. When you can substitute L is equal to 0 here, y of n, x of n. And here you can substitute L is equal to 0, y of n and x of n. Both are well the same. Comparing the equation 1, we find that Rxy of L is equal to Ryx of minus L. Or Yx of minus L. Yx. Because in the correlation, the changing of x and y, it is not obeys the commutative property. It does not obey the commutative property. So xy of L is equal to Ryx of minus L. You can substitute the minus as a folded version of the Rxy of L about L is equal to 0. The folded version. One signal is a normal and the other one is a folded version. Understood? Is a convolution whenever you can write as a correlation and the convolution relation. Rxy, one function is x of n with the convolution of y of n. You can write as x of n with the convolution of y of minus n. Is a relation between of convolution and the correlation. Is a function is a convolution. In terms of the correlation, it is a x of n with the convolution of y of n. One shifted version, other one is a folded function, and another one is a normal function. Okay, we can rewrite the equation 2 is also the Rxy of L is equal to sum of n is equal to minus infinite x of n y of minus of L minus n. Okay, you can take this as a y and here it is a x value, x of L with the convolution of y of minus L. So this equation is a relation between of convolution x of L with the convolution of y of minus L is related to the cross correlation function Rxy of L. One signal is a normal signal, another signal is a folded version of the signal. Autocorrelation function. Now, what is autocorrelation function? That is a correlation of a sequence within itself, or xx of L is equal to. Both the signals are the same, x of n and x of n minus L. One signal is a normal, another signal is a shifted version. Or otherwise, you can take the xx, one is an advanced function, x of n plus L and the x of. When L is equal to 0, it becomes of the energy signal. Sum of n is equal to minus infinite x square of n. You can say it is a x energy signal also. Okay. Autocorrelation function Rxx of tau is equal to integral minus infinite x of t x conjugate of t minus tau. It's a continuous functions. Or otherwise, we can take in one signal is advanced signal x of t plus tau x conjugate of t dt. For real functions, these two are the complex functions. One is with a delay function, and another one is an advanced function. For real functions, x of t minus tau dt, and x of t plus tau and x of t. These two are the real with the delay and advanced functions. All the equations what we have here, the same resultant value will get. Okay. For autocorrelation Rxx of tau, or in the cross correlation also, advanced function and the delay functions also, and complex functions and the real functions. You know the properties, we already discussed this one. Ryx of tau is equal to Rxy of minus tau. For real valid signals, the properties of cross correlation function for energy signals. Rxy of tau is equal to Rxy of tau is equal to one of the formula if I am using here, integral minus infinite to infinite. As of x and y, I used x of t plus tau, y of t dt. And now I am interchanging this as a yx of tau is equal to integral minus infinite to infinite y as t plus tau. And x now we can take the normal function dt. Or otherwise, if I am taking the y of t, integral minus infinite to infinite, and you can shift it with the delay function, the t minus tau dt. can use this also. Or otherwise, the integral minus infinite to infinite x of t minus tau into y of t dt. All the functions is the same. Got it, my students? X, y means here there is a minus of minus or xy of minus tau is equal. So using this, so r x y of minus tau or yx of tau is equal to r x y of minus tau. Understood? This is first one property in the energy signal. When tau is equal to 0, r xy of 0 is equal to 0, it becomes of xy of t, and y, here I am taking the cross correlation, it is not the energy signal. Autocorrelation will get the energy signal. X of t and y star of t is a two different signals. The signals are said to be the orthogonal over the entire interval. Okay, at the tau is equal to 0, it is not equal to the energy signal. It is integral minus infinite to infinite x of t, and the other signal y star of t of the conjugate becomes of orthogonal. You know, the c is equal to integral f of t into x of t dt. The numerator becomes 0. Then the c becomes a 0. We'll get we say that it's the two signals are orthogonal signals. Okay, and cross correlation for the periodic signals. For the periodic signal, r xy of tau is equal to only the change here, limit t tends to 1 by t, the integral minus t by t, the t by 2, x of t, x and y, I am taking the y star of t minus tau, or we can also written as 1 by t as 1 by 2t with the change of limitation from minus t by to the t by 2. T by to the minus t by 2 is a 1 by t, minus t to the t is a 1 by 2. Both are the same. Similarly, r yx of tau is equal to yx of tau is equal to y of t and x conjugate of t minus tau dt. But these two are not at all equal. R xy of tau is not equal to the r yx of tau. Understood, my students? And the properties of the periodic signals, the Fourier transformation cross correlation is equal to the multiplication of the Fourier transformation of one signal and complex conjugate Fourier transformation of the another signal. Okay, that is r xy of tau is a Fourier transformation relation, and if cross correlation is executed at the origin, tau is equal to 0, it becomes of orthogonal, and cross correlation exhibits a conjugate symmetry. R xy of tau is equal to r yx of conjugate of minus tau, and cross correlation is not a commutative. R xy of tau is not equal to r yx of tau. We already discussed this and we prove the properties also. Briefly, I am explaining here. Okay. See, the first property, the autocorrelation function, is an even function of the tau. That is, Rx of tau is equal to Rx of minus tau. Let us take here the Rxx of y, xx of tau is equal to integral minus infinite to infinite x of t, x conjugate of t minus tau dt. Now I am taking the conjugate on both sides. Rx x of tau with the conjugate. Here the x of t becomes x conjugate here. And already the conjugate becomes as a real function. So change the tau as a minus tau. Change the tau as a minus tau. And r conjugate integral minus infinite to infinite x conjugate of t and x of t plus tau dt. It is also equal to the same. So Rxx of tau is equal to Rxx of minus tau with the conjugate. Understood, my students? The autocorrelation is an even function of tau, that is Rx of tau is equal to Rx of minus tau. The second property, Rx of 0 is greater than or equal to Rx of tau. We already derived this function. Taking of the two signals and the square of that is very much greater than or equal to the 0. X square of t and x square of t plus tau, and 2x of t, x of t plus tau is greater than or equal to 0. and apply the integral on both sides. The first part is E, and the second one is also the E, and x of t and x of t plus tau is autocorrelation function. E is greater than or equal to Rx of tau. The E will get a tau is equal to 0 in the autocorrelation function. So R of 0 is greater than or equal to Rx of tau. The second property. Next, third property showing that it is autocorrelation function at tau is equal to 0 is energy signal. So Rx of tau, the formula we have, the integral minus infinite to infinite, x of t, x conjugate of t minus tau dt is Rx of tau. When tau is equal to 0, it becomes of integral minus infinite to infinite. Rx of 0 is equal to x of t, x conjugate of t minus 0. So x of t and x of t with the conjugate, it is a squared magnitude of x of t dt is equal to E. Okay. Rx of tau is equal. Got it, my students? Similarly, for the power signal also, the limitation is only with the variation. Limit t tends to infinite 1 by t, the integral minus t by the t by 2 x of t tau is equal to 0 becomes of a magnitude, squared magnitude of x of t is equal to the p. And here is equal to the energy signal. For periodic signals, if Rx of tau and Rx of conjugate of minus tau are complex conjugate to each other, then R of tau is equal to R conjugate of minus tau, called as conjugate property. We already seen the energy signal also. Now in the periodic signals, nothing but the power signals, taking the limit t tends to infinite 1 by t, the integral minus t by the t by 2. You change that as Rx of tau is a R conjugate function. Conjugate values will get the real, and the real function becomes a conjugate, and substitute the minus tau in place of the tau here. The equation is related to the correlation function only, the R of tau. So Rx of minus tau is equal to Rx of the tau. Okay. Now the correlation means comparison. There are two types of the correlations. One is autocorrelation and the cross correlation. Now only we discussed. The cross correlation, it is a measure of similarity between one waveform and the time delayed version of the another waveform. Cross correlation means one signal, it is a measure of similarity between one waveform and time delayed version of the other waveform. And here it is a two different waveforms. Cross correlation means it's a sinusoid here. Another f of t, I am taking the another square wave. At that, one signal is a normal signal and another signal is a delayed version. We are comparing these two. Or 1 2 of tau is equal to integral minus infinite to infinite f of t, and f2 of t is a delayed version of the tau. Here the tau is a 0 and a 0. It is shifted towards the right side with the tau samples. F2 of t minus tau dt, and you can take the complex. Autocorrelation function means it is a measure of similarity between one waveform and the time delayed of the same waveform. Here it is another waveform. Same waveform is the f of t is f1 of t is a sinusoidal signal and f2 of t is also sinusoidal signal, but f1 of t is a normal signal and f2 of t is a delayed version. So R11 of tau is equal to integral minus infinite to infinite f1 of t, and here it is not the f2, f1 only, but with the delayed version. What it matters to? Cross correlation means it is a measure of similarity between one waveform and time delayed version of another waveform. So I use here one is a sinusoidal, another one is a square, but the square is a delayed version. Suppose if I am taking the square as a normal function and sinusoid is a delayed function, let this as a f1 of t and this one is a f2 of t. You can write this R12 of tau is equal to integral minus infinite to infinite f2 of t and f1 the conjugate of t minus tau. Both are the same. So any one waveform and its time detail version of the another waveform, similarities you have to measure. That is the cross correlation. Autocorrelation means one waveform is a time delayed version of the same waveform. Is a majority to measure the similarity between those two. Is nothing but is a autocorrelation function. Applications of correlation. It is used to determine of a signal that are contaminated with noise. Next one. Cross correlation for the energy signals. V is equal to integral minus infinite to infinite x square of t dt, or here there is a they used f square of t. The cross correlation R12, one is a normal, another one is a delayed version, and R12 of tau delayed or advanced function also. Both are delayed means either you can shift it towards the right side or you can shift it to the left side. Okay. And 2-1, here the tau is a delayed parameter or scanning parameter or the scaling parameter. From the above two equations, cross correlation function of time by shifting f2 of t in positive direction by an amount of tau is equal to the cross correlation function of time by the shifting of f1 of t in the negative direction by the amount of tau. Negative direction is t plus tau, the positive direction is a t minus tau. And in this R12 of tau, it is a 2-1, but both are not equal, my students. The commutative property is not obeys in the correlation, it obeys in the convolution. Okay, so that is R12 of tau. By comparing with the convolution integral, we can define the cross correlation function. The relation between convolution correlation is R12 of tau is equal to f1 of t with the convolution of f2 of minus t. Minus t here. Understood, my understood. So minus t is one is a normal function, another one is a delayed version. Delayed, not the delayed, sorry, folded function. If f1 of t and f2 of t are even functions, then the cross correlation function becomes equal to the convolution. Even functions only, it is equal to the convolution. So difference between the convolution and the correlation. Convolution, f1 of t with the convolution of f2 of t is f1 of tau and f2 of t minus tau d tau. And here f1 of t, f2 of t minus tau dt. Tau is a dummy variable and the t is a dummy variable. Convolution is a function of physical time, the t, and it is a function of tau. It obeys the commutative law. It does not obey the commutative law. Obeys the commutative law means if we have, even you can interchange also 1 to 2 is equal to 2 and 1. But here 1 to 2 of tau is not equal to the 2-1 of tau. Okay. It is used to evaluate the response of the system for an arbitrary function f1 of t with the convolution of f2 of t in the frequency is a product. It is used to eliminate the noise from the signals. Okay, the application here, it is used to eliminate the noise for the signals. Now only we see what is the application of this. It is used to determine the signals that are contaminated with the noise. Eliminated. It is used to eliminate the noise from the signals. Got it, my students? Now you can see the properties of the cross correlation functions. It is x1 of f with the x2 conjugate of f is a Fourier transformation relation. The frequency. Okay. Proof of the Fourier transformation cross correlation of two signals is equal to the product of one signal and the complex conjugate of the other signal. Product of x1 of f with the x2 conjugate of f. See, in the convolution, we are saying that x1 of t with the convolution of x2 of t, what is Fourier transformation? Its Fourier transformation is x1 of omega and the x2 of omega. But the relation between of convolution and the correlation, we are saying x R12 of tau is equal to, in terms of convolution, x1 of t, second signal is a folded function, x2 of t. So now I'm taking that is a x1 of t with the convolution of x2 of minus t. Its Fourier transformation is x1 of t is same as x1 of omega and x2 of minus omega. x2 of minus t, it is a folded function. It's a folded function, time reversal property. So on the time reversal property, we'll get it is a complex conjugate x of f or x of omega, x conjugate of omega, x conjugate of omega, or x in terms of f, x1 of f, and another one is x conjugate of f. Got it, my students? And the second property, the cross correlation function is 0 at origin at tau is equal to, at tau is equal to 0, R12 of tau is equal to R12 of 0. That is the value is a 0 only. It's an orthogonal function or orthogonal function. x1 of t and x2 conjugate of t dt is 1 by 2t, the limitations of minus t by the t by 2. It is equal to 0. You can say it is an orthogonal function. At tau is equal to 0 in the cross correlation only. Then the third property, the cross correlation function satisfies conjugate symmetry. R12 of tau is equal to R21 of minus tau. It is not obeys the commutative property. We are saying R12 of tau is not equal to R21 of tau. But when it is equal, R12 of tau is equal to R21 with the conjugate and change of minus tau as a minus tau. So see here, I'm taking the periodic signals, limit t tends to infinite 1 by t the minus t by the t to the t, x of t and x conjugate of t minus tau. And x2 of t, the two functions we are taking, put that the tau is equal to minus tau in the 2-1 function, minus tau, limit t tends to infinite 1 by t the integral minus t by t to the t, x2 of t, x1 conjugate of t plus tau dt. Apply the conjugate on both sides. R21 conjugate of minus tau is equal to limit t tends to infinite 1 by t the integral minus t to the t, x2 conjugate, because it is a whole conjugate means already the real function is conjugate. Complex function is now the real x1 of t plus tau dt. Now, let us t is equal to t minus tau. Replace t is equal to t minus tau. Dt is equal to d tau. Okay, not the d tau. Dt is equal to dt only. The tau is a constant here. So limit t tends to infinite 1 by t the integral minus t to the t, x2 conjugate of, I'm replacing the t as a t minus tau, and here the t plus tau, the t as t minus tau plus tau is a t on. T get cancelled. So x2 conjugate of t minus tau, x1 of t dt. Now these are equal to the cross correlation function R12 of tau. So when the interchanging of the two functions are not equal, because it is not obeys the commutative property, but it is equal when you can interchange, apply the conjugate and change the tau as minus tau. Okay, my dear students. The cross correlation does not satisfy the commutative property. See, these are as though equations are not same. 2-1 of tau, these two are not equal. The cross correlation function of energy signal is given by R12 and R21. So both are not equal here also. Now you get the problems of autocorrelation function. Determine the cross correlation function. Determine the cross correlation function or xy of tau or here it is taking Rxy of tau of the two signals G1 of t and the G2 of t defined by G1 of t and G2 of t is defined by G1 of t is a cos 2 pi f1 of t plus theta 1, the limitations of 0 to t, and G2 of t is a cos 2 pi f2 of t plus theta 2 from 0 to t. The cross correlation is given as one signal is a normal signal, another signal is the delayed version. R12 of tau is x1 of t and x2 conjugate of t minus tau dt. In terms of G1 and the G2, the cross correlation G1 of t and G2 conjugate of t minus tau dt, and A into, now the G1 is given as A into cos 2 pi f1 of t plus theta 1 into A cos 2 pi f2 of t. The t now it is a t minus tau. And now here it is, I am taking the lambda cos 2 pi f2 t minus lambda plus theta 2 dt. Okay. So A into cos 2 pi f1 of t plus theta 1, we can expand this function as A cos 2 pi f t minus 2 pi f2 lambda plus theta 2 dt. You know, cos A minus B plus cos A plus B is equal to 2 cos A cos B. Okay. So A into A, you can take the A square. A into A is A square, and the limitations also are changed because 0 to t only. Cos A plus B into cos A minus B. Cos A plus B. Take it as a cos of A, and this one is a cos B. Cos A minus B, cos A is 2 pi f1 of t plus theta 1 minus the B term is 2 pi f t of 2 to t minus theta 2 plus, here the cos is a minus 2 pi f2 lambda. Again it is a plus cos of A plus B. What is the A here? 2 pi f1 of t plus theta 1, and B is 2 pi f2 of t minus 2 pi f2 lambda plus theta. Okay. Now you can split this as two parts of integral. The first one is integral cos with the limitations of 0 to t. Cos integral is a sine, and second integral is also cos only. Integral cos is a sine. Okay. And the coefficient with respect to, we are applying with the dt, take only the coefficient is 2 pi f1 and here the 2 pi f2. So 2 pi f1 minus 2 pi f2. And for the second integral also, see here 2 pi f1 plus f, remaining all it is a constants. Got it, my students? A square by 2, and after substituting the upper limit and the lower limits, when you can substitute the upper limit instead of the t value here, sine 2 pi f1 and minus f2 into t, theta 1 minus theta 2 plus 2 pi f2 lambda minus, and at the t is equal to 0 here, sine of theta 1 minus theta 2 plus 2 pi f2 lambda. Because the t only the 0 and the capital T. For the second one also, sine 2 pi f1 plus f2 into t, as now it is a capital T, theta 1 plus theta 2 minus 2 pi f2 into lambda. Okay, minus, when you can substitute the 0, the first term is a 0 here, theta 1, theta 2 minus 2 pi f2 lambda, and denominator is the same. And whole multiplied is a square by 2. Okay. So totally the R12 of tau is equal. R12 of tau is equal to, we got in terms of a square by 2 sine function and the plus sine of the other function. And find the cross correlation of the function given x1 of t and x2 of t in terms of the graphical representation they given. From -1 to 1 is varies. Okay, x1 of t, by using the slope equations from -1 and the 0, and here the 1 and the 0, the slope 1 and the slope 2, we can write as from -1 to the 0 is 1 plus t, and from 0 to 1, the 1 minus t. By using this y minus y1 is equal to y2 minus y1 by x2 minus x1 into, see what is a y1? So let us take here, it is a x1 y1 and here x2 y2, the two functions. Y minus y1 as a 0 is equal to y2 is a 1 minus y1 is a 0, and x2 is a 0, x1 is a minus of minus, it becomes a 1, and x of x minus x1 is a plus 1. So y is equal to 1 by 1 is a 1, x plus 1. We need the x value is a t, so y is equal to t plus 1. What is the y? The x of t. So x of t is equal to 1 plus t for this function. Okay, similarly the 1 minus t. We take this one is a x1 and the x2, 1 and the 0, and x1 and y1, and this is x2 and y2. We'll get the 1 minus t. Okay, and similarly for the second one, here the -1 to 1 with the magnitude is a 1. x2 of t is equal to 1 from -1 to 1, and x2 of t minus tau is equal to 1, where the t is tau minus 1 to the tau plus 1. Got it, what is? Because it is a delayed version. So R12 of tau is equal to integral minus infinite x1 of t and x2 of t minus tau dt. Okay, my dear students. Now at the tau is equal to -2, there is no any overlapping occurs of these two signals. Means the x of t only are delayed function. The fixed we can take as x1 of t, and it is a delayed at the tau is less than the -2. It is varies from -2 to the -1 only. And next we can shift towards one sample, -2 to the here 0. There is an overlapping occurs. That overlapping value will get as 0.5. And in the third case, still it is moved towards -1 to the 1 here. There is an overlapping. Again, you can find the value. The value is a 1. And further, you can move that the value towards the right side as the value is a 0.5. And still it is moved with a 0. So the first value here is a 0, 0.5, 1, 0.5, and the 0. You can draw the value from -1 to the 1. It increases from 0 to the 0.5 and decreases 0.5 to the 0. So 0 to 0.5, and again it is a 1 and is a 0.5 and is a 0. The R12 of tau is getting from -1 to the 1 is increasing and decreasing the value.